Okay, guys, section 5.9 is probably one of the easiest sections to do, but I at least want to show you, instead of just giving you the formulas for the trapezoidal rule and the Simpsons rule, I want to at least try to derive the trapezoidal rule for you. So, let me draw a little picture. Let me say that we want to, with this random curve here, that we want to estimate the area under the curve from 12 back to, I guess maybe I should say from 2 to 12, or -4, -6, I don't know, let's go -6. -6 to 12. Okay, now to illustrate this, I definitely want to pick some, we want to think about how wide this is. So how wide is it between -6 and 12? I'll give you a second. Okay, you got it? So it's 18 between there. So I can divide this up into twos, or, into two rectangles, actually a different shape, into 9 of them, into 3 of them, into 6 of them. Yeah, I think I like 6. So since it's 18 long, let's say that every 3 units we want to draw another height. So that goes to -3. Then we'll go to 0. And we'll go 3. Now notice where I'm drawing these heights. I'm not drawing them above or below the curve. I'm drawing them right to the curve. And we'll go to 6, and then we'll go to 9, and then we go to 12. So each one of those lines that I drew for heights is 3 units apart. So they're all evenly spaced. Now what I want to do is I want to actually connect these endpoints, and I want you to see the shapes. The shapes are what? Does it help if you turn your head sideways? If you turn your head sideways, see, like, I don't know, let's say this one right in here looks like this, right? So now can you see what that is? That's a trapezoid, where this is one of your bases, this is one of your bases, and this is your height. The base, the base, the height. In this trapezoid, here's a base, here's a base, here's your height, and so on. So let's start the first one. Here's your base, here's your base, here's your height. So you want to remember, what is the formula for the area of a trapezoid? The area of one trapezoid is 1/2 times the height times the sum of the bases. And maybe in class tomorrow we can graphically see why. If you never saw that derived, it's pretty cool. If you duplicate a trapezoid and turn it on top of itself, we get this parallelogram. I think we might have done that in class before. So that's the area for one trapezoid. Well, let's call this height x sub 0. And then this is x sub 1. Then we have x2, x3, x4, x5, and x sub 6. And if you count them, we have 6 trapezoids, right? Here's the top of the first trapezoid, second, third, fourth, fifth, sixth. So if we want to add the areas of those trapezoids together, it would be 1/2 times the height times the sum of the bases. Now what are the bases for this trapezoid? This x value is x sub 0. This x value is x sub 1. And I guess I should say we're going to call this function x. So our first height is f of x sub 0, and our second height is f of x sub 1. And hopefully you can picture doing this all the way across. And we're going to end up with, at the end, 1/2 times the height times the sum of the bases, so f of x sub n minus 1. Oh, and right now this is 6, right? So this would be f of x5 and f of x6. I almost wrote a 6. But in general, if you're looking at n rectangles, this is what the formula would be. Now, maybe I didn't write enough terms. Let me squeeze in the second term here. 1/2 times the height times the sum of the bases. Hopefully you can't hear my dogs. Okay. So what you're going to notice is that this height occurs once. This height's going to occur twice because it's a base for this trapezoid and it's a base for this trapezoid. This height is a base for this one that I just traced and for this one and so on. So all of these lines in the middle are going to be repeated. So if we try to clean up this formula a little bit, we could factor out the 1/2 times the height and then all the sums of the bases. You would have one of these x sub 0s plus 2 of the f of x sub 1s plus 2 and so on. Then we would have 2 of the second to the last one. I guess I could be calling this one x sub 5. And then 1 of the x sub 6, because I'm going to write the actual formula down at the bottom. Okay, so I factored this 1/2 times 3 out. How did we get that, really? Well, the 3 is b minus a over n. That's where we got the 3 in the first place. So b minus a over n times 1/2 is going to give you b minus a over 2n. That's what gets factored out. And then we have f of x sub 0 plus 2 f of x sub 1 plus 2 f of x2 plus dot dot dot, and I'm going to run out of room. So I want you guys to write right here, plus 2 f of x sub n minus 1. And then the last term would be just 1 f of x sub n. So please do put that term in here. The 2 f of x sub n minus 1 would go in there, just so you would remember that the coefficients go 1, 2, 2, 2, 2, 2, 2, 2, 2, all the way to almost the end, and then 1. Alright, Simpsons Rule I'm not going to derive in a picture for you, but what it comes from is kind of taking curved parts right here instead of trapezoidal parts, little parts of parabolas or quadratics, which makes it even a better estimate for the area under the curve. You saw how good a trapezoidal was. So Simpsons Rule, just write it in a different color, is that the area under a curve from A to B approximately equals b minus a over 3n times f of x sub 0 plus 4 f of x sub 1 plus 2 f of x sub 2. I really wish I would have left more room. Plus 4 of x sub 3, and so on, plus dot dot dot, plus, and the second to the last term has to have a 4. I'm going to fit this in here somehow. Has to have a 4 for a coefficient, and then the very last term gets a 1 for a coefficient. And that's your formulas. So definitely pause and write these formulas down. If they're too messy for you, then pause, look them up in the book or Google them and write them down. We're going to use them on the next 2 pages. Okay, if I wait for ideal recording situations for the rest of this, it's never going to happen. So you're going to hear the dog eating in the background. You're going to hear some kids, and you're going to hear some TV, maybe. But I had to put this picture-in-picture here so you could see the steps on the calculator, because the whole rest of this is definitely about what you're going to put in on your calculator. So look at the example here. We're finding an approximation for the integral from 2 to 4 e to the x over x. Now, why do we have to do this on a calculator for an approximation? It's because you can't integrate that function, at least not with the current methods that you know now. So you want to start out by having that in your y equals, which for some reason this has a huge glare. Okay, there we go. So you want to make sure you have the function in your y equals. And then I'm going to probably pause this as I start to put in the rest of it, because it can be a little bit time consuming. But we're going to start with our b minus a over 2n. Now this says for these, let me point out, we want to find, it actually doesn't really say, so let me give you the directions here, some good directions. We're using the trapezoidal rule to approximate the sum, and we're using 8. I believe we're using 8. I'm going to go off of memory. We're going to use 8 trapezoids. Okay, so to split from 2 to 4 up into 8, what you want to keep in mind, if we're splitting from 2 to 4 up into 8, you can do it this way. You don't have to use a formula. You could take 2 minus 4 divided by 8 and keep adding that fraction or that decimal onto each number. But it's just as easy, I think, to do this and then cut that in half and in half, right? Cut that in half and in half. So you could see that this would be 2.25, 2.5, 2.75, and so on. 3.25, 3.5, 3.75, and 4. So what am I going to do? I'm going to start with my b minus a over 2n, and that's what's going to go on the outside. And this is going to give me a 2, and this is a 2, so they cancel out. So now I am left with a 1/8 on the outside times f of, and I have the function stored in y1. So I'm just going to do y1, and you know to go, you know where to get your y1. Y there's to the right, enter, enter. y1 of 2 plus 2 y1 of 2.25 plus, now this is what it looks like so far, okay, 1/8 times y1 of 2, so basically f of 2, plus 2 f of 2.25, and I'm going to go plus 2 f of 2.75, and so on. I'm going to pause this and finish. Okay, let's see. So this is what you should have. Let me just, you could go back through and pause this if you need to see anything. But all of the 2 f ofs are all doubled until, or all of the f ofs are doubled until you get to the last one. And then you have plus f of 4. So let's hit enter and write down your answers. I don't see it saying to how many decimal places, so let's go 14.720. Alright, now let's do Simpsons. All we're going to do for Simpsons is hit second enter and change these 2's, like that 2, to a 4. Leave the next 2 alone. Change this 2 to a 4. Leave the next 2 alone, and so on. So that's all you need to do. Oh, and you also have to change this 1/8, right? Because that was b minus a over 2n, and now you want b minus a over 3n. So I'm going to pause. You try to get it on your calculator, and I'll get it on mine. Okay, so check this out. Now I have 2 over 24. I could have had 1 over 12, but quite frankly, I just couldn't reduce it in my head quick enough. All the other ones, again, I changed the first 2 to a 4, and then left over, you know, and then the next one was a 2, and so on. And I knew I was right when I got to the second to the last one. I changed it to a 4. Now I'm going to hit enter, and I get 14.676. So that's a slightly better estimate, so you write that down. Lastly, let's check what the actual integral is. So I'm going to check the actual integral by going math 8. Math 8 gives me the numerical derivative, and remember, yours might look different than this if you're not in classic mode. But I'm going to go y1, comma, with respect to x, comma, oh, totally wrong thing. I don't want the derivative, I want the integral. Math 9, so sorry. Okay, variables y1 with respect to x from 2 to 4. And I'm speaking fast because I know I have to hurry up if I want to get this done before 15 minutes. Okay, those are your arguments. Hit enter. And that is the exact value. Look how close that is to Simpsons Rule. Okay? Okay, pause and enjoy. And I have 18 seconds left to say, and this is your homework. So there you go, and I will see you guys tomorrow.